So you've spent a little bit of time working with ellipses and graphing them. Now, can we give you information about them and you come up with the equation? So we're kind of working backwards today and in this section. So what I want to be able to do is give you information, you write the equation for the ellipse. So in example 1 here, we give the center of -5, 7, and we know that a equals 5 and b equals 2, and our major axis is going to be vertical. So how would I tackle this problem? The first thing I would suggest that you do is go ahead and graph what you know. It's always good to have a piece of graph paper alongside you when you're doing these. So I'm going to come over here, -5, and I'm going to come up my 7. So there I know is my center. So if you want, we can go ahead and also kind of create what this equation is going to look like. So we know that we're going to have something, or actually our x's are going to come first here. So our x's squared divided by something plus our y's then squared divided by something is going to equal 1. I also know that the x value is going to come along from the center of my center point. So I know that my x value is going to be the opposite of that -5. So I'm going to have a +5 with my x. The value that goes along with y is going to come from my center. It's going to be the opposite of that number. So I know I'm going to have a y - 7 being squared. I know I have a major axis being vertical. So I know that this is going to open, or it's going to be stretched vertically here. So I know it's going to go much higher and lower than it is going to go left or right. Since I know that a equals 5, I know then it's going to go higher in this direction, 5 units. And my lower point there is going to be in 5 units. My b value is 2, so from here I'm going to come over 2. So notice it's going to stretch, it's going to have that major axis going to be going up and down. So if I were to draw that in, here would be kind of what my graph or my ellipse would look like. So how does that play into it? Well, notice we're stretching higher and lower, so my major axis being vertical goes along with the y's, so my y value here is going to be my a. If I take my a and square it, I'm going to end up with 25. Recall that the general equation, I guess I should have put that up there, x minus h squared over, this could be a or b, and then y minus k squared. This again could be a or b, but my a value always goes with the major axis. So in this case, I'd be a squared, and in this case would be b squared equal to 1. Well, in that case, then I know my b value is 2. 2 squared gives me 4. And that's going to give me my equation of this ellipse. Now that was a little on the easier side of what we're going to see. They do get much more complicated. We can get into a lot of different things as we get into these problems. So here we have the foci at 0, 3, and 0, -3. So again, I'm going to go ahead and plot those points. So I have my 0, 3 and my 0, -3. I know the foci are going to lie on the major axis. So if my major axis is 10, or the length of the major axis is 10, I know that it's going to be a vertical major axis. I also know that my foci are equidistant from the center. So equidistance from here would be 0, 0. In order for my length of my major axis to be 10, I know again the outside vertices have to be equidistant from the center. So half of 10 gives me 5. So I'm going to have my two of my vertices here. I'm going to know at 0, 5 and at 0, -5. That also tells me my a value. My a value in this case is going to be 5 because I'm 5 units from the center. Can I find my b value? Because that's what I'm going to need. Well, recall that c squared equals a squared minus b squared, where c is the distance from the center to the foci. So I know that 3 squared, which is 9, is going to equal my a value squared, 25, minus my b squared value. Go ahead and solve for b squared. We can subtract 25, so we get negative 16 equals negative b squared. Divide by negative 1, so 16 equals b squared. Take the square root of both sides, and I end up with 4 is going to equal b. Not interested in a negative value. Really, we're interested in that b squared value. So what is the equation going to look like? Again, I can go ahead and set up what I know. And everybody should be able to at least get a template for our equation out there. I know that the x and the y value, numbers with the values, come from the center. In this case, it's going to be 0. So we can put in the plus 0, or you can leave it blank. Doesn't matter. We know the major axis was vertical, so we know the a squared is going to be under the y's. So in order for that to happen, we're going to take our 5 and square it to get 25. The number under the x's then is going to be our b value squared. In this case, it's going to be 16. And that's going to give us our equation of this ellipse. Oh, look at this one. A little more complicated here. Here we have vertices, and that's all we're given. So can we find the equation given these vertices? So again, I would go ahead and graph what we know. We have the point 1, 1 there. We have the point 1, 7. We have the point 0, 4. And we have the point 2, 4. So there's my ellipse. If we kind of draw in, and again, this is a vertical major axis. I guess I like the verticals today, huh? So what does that allow us to do? Well, if we were to draw in a line through the vertices, we're going to see that they're going to intersect at this point. And that point is going to be our center. So we can go ahead again, set up our template. So our vertex is going to be at 1, and 1, 2, 3, 1, 2, 3, 4. So we have x minus 1 and y minus 4. Our major axis is going to be vertical here, so we know it's going to go along with the y's. So our a squared is going to be below the y. That a value is from the center up to the vertex. So we have 1, 2, 3. 3 squared gives us 9. Our x value, or the b value in this case, b squared, is going to be the distance on that minor axis. In this case, it's 1, and 1 squared gives us 1. So that gives us the equation of that ellipse. And here I have one more. This one's probably going to be our more complicated one, probably being example number 4. Let's see what we have. Here we have the equation. The major axis is x equals 3. So we come over here to 3, and that's an equation. So we can go ahead and draw in that line. The length of the major axis is 10. Well, we don't know where the center is at this point, so we can't start plotting our points. But we know that if we knew the center, we would go 5 units in both directions in order to get the length of that major axis, which would give us our a value. But notice we're given the equation of the minor axis. The minor axis is y equals 2. So y equals 2 is going to go through here. Where these two intersect is going to be the center of my ellipse. So now I can go ahead and set up my general form of this ellipse. So I know that x is going to be subtracted from 3, or x minus 3, and then 2 is going to be the y value, so I'm going to have y minus 2. I know the length of the major axis was 10. Again, we can come up 5 units. We can go down 5 units if we need to. So we know that our a value is going to equal 5. We also know that it's stretched vertically, so along with the y-axis, so then we're going to get 25 under the y minus 2 squared. Our x's, our minor axis, is 2 units long, so there's going to be our points there. So our b value is 2, and 2 squared gives us 4. So that gives us the equation of that ellipse. So the biggest thing I want you to see today is graph what you know and then set up a general equation and start plugging in things so you can come up with that equation. If you have questions, give me a holler and we'll go through some more examples. Good luck.